All right. Yeah. Thanks everyone. Thanks everyone for attending. And yeah, I've already been introduced a bit, at least. Yeah, I'm Mark. I work at Typefox, and we do a lot of like Ben and Johannes have already introduced our company. I believe we do a bit of DSL, IDE stuff, and so on. Some graphical engineering as well. And I also work on Fridays at the University of Applied Sciences in Hamburg. I do math in my lectures. And I'm a project lead at the Eclipse Theia and Eclipse Langdev projects. I do quite a lot of open source work in general, less of customer work or actual programming. Anyway, so let's get started with the actual topics at hand. First, I'm going to explain a bit some stuff about notebooks or how we know them in at least in this context, and maybe a question beforehand: who's actively, regularly, or sometimes at least using like Jupyter Notebooks or something like that, like for research or something similar? Okay, that's a few. And who's generally like knowledgeable a bit about notebooks? Like, okay, yeah, so it makes sense to explain it a bit as well. All right, and then we're going to talk about IDE integrations and especially the Theia IDE project. And then I'm going to show you a bit how this thing works in general. And we will dive a bit into the technical aspects as well, so this will be more of a technical talk than something like a case study or something. All right, so the notebooks generally, or Jupyter Notebooks in particular, started off with the interactive Python or IPython project. It's fairly old, started in 2001. And the idea basically was just to being able to execute Python snippets. Python generally is already an interpreted language, so just being able to execute certain code lines was kind of a given already. And the idea basically was that we could contain some context, some variables that stay over, that kind of stay in a kernel that we can essentially just execute small snippets one by one and then have some more interesting output with that, which in particular, in this case, was multimedia output. So it wasn't just text output. We just don't get like, well, a small table of like Markdown or something, but rather actual multimedia files like images, interactive graphs, SVG files, whatever. So this was actually kind of a new thing in this regard. This naturally evolved eventually in 2011 into Python notebooks, which was actually, basically took over the main features from IPython, so interactive Python, and presented everything as a web app. And not only did it present the like snippets in a web app, but actually enabled you to also write documentation and formulas and what kind of documentation you like, essentially, in between those code snippets. And so you could create any kind of documentation or maybe something for mentoring, for teaching, for just documenting stuff as well, like documenting ideas and getting just some essentially utility for teaching as well. And so it's a very good way of essentially sharing ideas and sharing code and sharing knowledge. And all of that is presented as a web app. So it's fairly accessible as well. You could even, it's not necessary that it runs on your own computer as well. You could have it on some server. And yeah, that's fairly nice. Some larger companies as well have used that in their cloud offerings as well. But what they've used in particular was actually Jupyter Notebook, which split off the IPython project in 2014 and actually was completely language agnostic. So the idea behind Python notebooks was that, well, you could use Python snippets and documentation and so on and execute those cells or code cells one by one. But everything was kind of bound to Python and the Python kernel. But, well, the project noticed, well, actually, like 90% of that is completely language agnostic. Like the front end and the whole idea of actually having kernels isn't something that is completely bound to Python. And so we could actually have something that is, well, split off from the Python project, or IPython project in particular, that just connects to a Python kernel for its tasks. If you want actually to work with Python, but if you want to work with another language, you could write the kernel. Has anyone actually tried writing a kernel ever? I did. It's horrible. It's not a good experience, but we'll talk about that later. Anyway, and that's become hugely popular. I've mentioned it's being used by large cloud providers as well, like Google Colab, for example, is actually just a different front end for a Jupyter Notebook. Okay, before going into the IDE integrations themselves, let's talk about Theia as a project. So Theia is essentially VS Code, just to say it plainly, but with a huge extension mechanism. So essentially we created, or Typefox created rather, I wasn't a Typefox yet at that time, created an IDE platform in 2017 that was supposed to be like a spiritual successor to the Eclipse Rich Client platform. Because at that time we had kind of quite a lot of clients, for example, that wanted something in the web, because back then everything kind of moved in the cloud. And so the Rich Client platform, RCP, wasn't really a good fit for them anymore. Instead, they wanted something that could run in the cloud, maybe even something that could run on the desktop. And so we started the Theia project. Initially, it was quite different from VS Code. It had kind of its own extension mechanism that was compile time and not something like a plugin. But eventually, we started adding VS Code extension support and so on. We now call them VS Code plugins because we already had extensions, and in order to prevent naming conflicts, we now have plugins. So VS Code extensions are actually called plugins in our world, which leads to a lot of confusion. Anyway, and because we had to support VS Code plugins, we kind of started moving in the direction of VS Code with its UI as well. And so it kind of looks like VS Code. I mean, there's virtually no difference except for the one little Theia icon that you probably can't even see. Anyway, so it's the Theia IDE project. It looks like VS Code, but something that is very interesting in this regard is, because I mentioned there's a compile time extension mechanism, you can make it look, or rather feel like a different IDE. And so a lot of companies came up with their own products based on the Theia IDE framework. For example, ARM built their Embed Studio, which is an IDE for their microcontrollers based on Theia. It features a bunch of C and C++ compiler includes, or rather built-ins, in order to get directly started with C++ programming out of the box. It's a similar thing with Arduino, which built their new Arduino IDE on top of Theia to support, well, their Arduino microcontrollers. Then we also have SmartFace, I believe they're called. They do like app programming inside of that, so they were their own kind of like app or phone app engine. And then there's View Engine, or rather View Studio, which is my personal favorite because you can do Nintendo Virtual Boy programming on that. That's like the grandfather of all virtual reality headsets. And so I think that's fairly cool. They built their own engine with that, and so you can write Virtual Boy applications, or games rather, using C and C++ with them. So that's arguably one of my favorite implementations of the Theia framework. I love that. Anyway, so that's Theia. You can use Theia for any kind of application or kind of IDE thing in general. There are a lot of people who are using Theia for a lot more than just IDEs, actually, but I'm not endorsing that because it usually isn't that good in the end. Anyway, so enough for Theia. Let's go back to Jupyter. So eventually, most people that write Jupyter Notebooks, or at least a lot of them, are like data scientists, Python programmers, just kind of software engineering people in general. And Jupyter Notebook, the Jupyter Notebook application isn't really an IDE. So you are able to load a workspace, open Jupyter Notebook files, and so on, but it's not really an IDE. And so people don't really want to, for example, context switch all the time. If you're writing Python code and maybe you want to write some documentation in between and so on, you don't constantly want to switch between your IDE, something like VS Code, and Python Notebook, and so, or Jupyter Notebook rather. And so Microsoft came up with a way to kind of include Jupyter Notebook into VS Code via a VS Code extension. That was kind of technically difficult, as it had to use the VS Code extension mechanism in order to display everything. So everything was displayed as a web view, and it had kind of complicated Python support, as in, from an extension, it's pretty difficult, for example, to get access to the Monaco editors inside of VS Code. It's pretty difficult to get access to the actual like Python extension support and so on. So they had to do a lot of workarounds in order to get everything working correctly, which was obviously a lot of effort. And what I actually also noticed when I was working with that, it's relatively slow, at least slow compared to what Jupyter Notebook offered and what VS Code is actually offering now, but I'll talk about that later. And the cool thing about actually the VS Code extension that was offered previously was that it worked in Theia out of the box, because in Theia we also offered the VS Code extension support, and we also offered the WebView extension support, so that's essentially just an iframe running in the browser. And so because we offer all the API that was necessary to get that running, we could actually make that work in Theia out of the box, which was fairly nice. So people could just download the extension and it works. Perfect. But we still had the issue, and it was kind of slow. So the Microsoft team at VS Code came up with a different solution. What they wanted to do was they wanted to have a native integration of notebooks in VS Code itself. And so that was something they worked on for quite a bit. It took a while until the API was finalized and so on. But eventually in 2021, they released the API. And that was actually really cool, because as an extension developer, you could pretty easily develop something new for the VS Code notebooks. Because similar to Jupyter Notebook, it was completely language agnostic, while the old Jupyter Notebook extension was purely Python. The new one is, yeah, well, as I just mentioned, completely language agnostic. So you could just write any custom kernel with the new VS Code API. And you just get the code that is currently placed in the cell, and you can do anything with it. You can execute it and or interpret it or whatever. And so that was fairly nice, because now the VS Code extension community are now able to create their own extensions for any kind of language, and even for, let's say, more esoteric languages, but I will come to that later as well. Okay, well, now we are in a bit of trouble. I've introduced the Theia project already, and now we've seen, well, VS Code has introduced a fairly large API service now for notebooks, and we kind of had to play catch up. And we didn't, really, for 2 years. Actually, a lot of people came up to us, they asked, like, yeah, well, do you have VS Code notebook extension support? And we told them, no, it's like 30,000 lines of code in VS Code. We just don't have the bandwidth to do it. And so luckily, some customer came up to us, they asked, like, well, can you do it? We told them yes, but it will take a lot of time. And they actually sponsored us to do it, and so VS Code Theia now has notebook support as well, so that's fairly nice. I want to explain in a bit of an architectural overview how it generally works. So the problem is generally, in the front end, we have a big notebook editor containing editors and like outputs, documentation, and so on. And in the back end, we have an optional Python, but generally a notebook kernel. So the question is, how do we connect one and another? And the solution generally is fairly simple. We have some kind of notebook selection service in the front end, where we just say, well, we have some kind of arbitrary kernel that we can register. And the plugin host, which is concerned with actually hosting the VS Code extensions that we are running inside of Theia, is now capable of communicating with the Python kernel, for example, and then registering that inside of our front end. We have a smart RPC mechanism that makes that fairly easy. And so once we have the registration going on, we can just actually execute code through the kernel and get a result back immediately. Or basically immediately, assuming the code runs fairly fast. And even if it doesn't, that's not too bad. I will show an example of that later as well. And so that's fairly nice. So we have this kind of back and forth between front end and back end. That's fairly easy. The more complicated parts are actually, well, when we drill down into the notebook editor itself. I've mentioned we have editors, outputs, and so on. Things are getting a bit more complicated. And I will show a particular challenge in more detail as well. So let's get started on the outputs in particular. They are just kind of an isolated component in the widget, and so we can show them in the architecture as well as an isolated component for now. They just interact with the kernel, right? We send a request for execution. We get a result back, something like HTML, something like text or an image or whatever, and we just display it. Just displaying is obviously a simplification, but we will get to that. Anyway, editors are more interesting actually, because once we isolate that, we get all the we want all the kind of features that we already had in VS Code or in Theia for all the language support as well for our notebooks, right? So we already have a VS Code plugin for Python, and so we want our notebooks to have Python support as well, right? If I want code completion instead of a Python notebook, I just want essentially the Python extension to just take care of it. And so what the idea is essentially we just tell the plugin host, which is concerned with all the language services, that essentially every cell inside of a notebook is its own editor. We just say, well, you know, you have this kind of 5-line code cell. It's kind of its own file. Just trust me on this. And just give me all the diagnostics and references and code completion results you would usually do for a single file if it wasn't contained in this large document. And that works surprisingly well. We just have to do a bit of UI, let's say, hacking with that in that regard. And we got all the features that we are used from text editors out of the box for notebooks. So that's fairly nice. That's the general architecture. The architecture generally is fairly simple. This feature is roughly like 20,000 lines of code in a fairly large code base already. So it took a while, but eventually we got it running. I don't think it's totally running. I can show, like, it's not perfect yet. I can show a few issues with it later as well. But because I included in my demo, that's quite unfortunate. But one thing in particular I want to talk about is notebook layouting, because I've mentioned that we show the outputs of the kernel as just simply showing them, but it's not that easy, right? Because, for example, in this case, it's quite small probably, but you can see a code editor, some output, some text output, some more text output, and then the bottom, an interactive graph actually, made by, I think, with Plotly. And you could argue, well, okay, we can take a look at this naively and just say, well, it's just a code snippet, then some output, a code snippet, then some output, and so on. And that works fine, in theory at least, if you want to make it very slow. Because each of those outputs is its own iframe in the browser, and each iframe needs a specific URL, you need to load it. Loading an iframe takes like half a second, loading hundreds of iframes takes a minute. And so that brings the browser to a crawl, or your desktop IDE, and so we don't really want that. And we had that, we didn't like it, because it was just incredibly slow. And so, yeah, these are individual iframes, as mentioned already. And so our solution, and the same solution that actually the VS Code team came up with, was to simply use a single iframe. Easy, right? Okay. The idea is that we just have kind of like a backlayer iframe that displays all of the outputs by itself, or collectively rather. And then on top of it, we just place the editors appropriately. And placing the editors appropriately, and the outputs in general as well, like we need all the spacing and so on, isn't that easy as well. But there are quite a few interesting solutions as well to that. And the idea is basically whenever we lay out something in our browser, we just tell like the other side, which is either the cell editors or either the output, which is running in its kind of own process, it's in an iframe, that we just layouted something, right? We just tell them, hey, we have this new code editor, or we just added a line to an existing code editor. It's now this height. And so whenever we change something, we get a new height notification, and we do the same in reverse as well whenever we change or add an output. We just tell the code says, well, now you have a new output. Please adjust everything. Okay, cool. So now you get an idea on how like some of the problems that we encountered looked like during our implementation of like notebooks in modern IDEs. Coming back to the initial topic of our talk, and with that out of the way, I will actually show you a demo now. And eventually, I will also come back to the topics of DSLs, by the way. Eventually. Okay, so that doesn't work for some reason. Oh, because I didn't actually exit the presentation. Okay, perfect. All right, so that's a notebook and running in Theia. If you've ever seen a notebook running in VS Code, it looks very similar. That's because we just took the same UI eventually. So we kind of copied it, so to speak. We didn't necessarily take the same code. It's like its own implementation, but we took a lot of effort to make it look like it was VS Code. Anyway, So this is just a notebook with some very simple code in there. We have a bunch of documentation for it as well. And we can actually take a look how things are running as in real time. So we have connected to a Python 3.11 kernel in there as well. And now we can just run some simple printing code essentially in a loop, sleep in between, and we immediately see, well, okay, everything that we are printing out immediately appears in our output. Pretty nice. And that's all running in a backend, so perfect. Yeah, so that's a pretty simple example. We have also more complicated examples as well, which aren't perfectly loading for some reason. Anyway, for example, we can show some more interesting graphs as well. So I just took some random Python notebook actually from the internet. I have no idea what it's about. Gravitational waves apparently, and well, you can really do any kind of output with that. It's not limited by any way because it's just HTML. So since you can basically do anything with HTML by now, and JavaScript in particular, so it's not only HTML, but you can inject any kind of JavaScript in there as well. You can just do anything with it, and so the outputs are just kind of used. They can be used quite extensively. And so that's Python. And now coming back to the topic of like DSLs, you see, I've mentioned that the API is completely language agnostic. And so people come up with ideas how to make their work a bit easier. For example, if you're having trouble managing like a large code repository, for example, the VS Code extension does that, the VS Code team has an issue with that. I believe they have like multiple thousands of issues open at any time. And so managing that and triaging new issues and so on becomes very, very complicated, very fast. And so what they worked on was a GitHub notebook extension, a GitHub notebook kernel. And so, for example, I can essentially just use the GitHub search DSL essentially, which you can use to search for issues and PRs and so on, directly in notebooks. And I can also use placeholders. For example, I can create a placeholder for my repository, which is Langdev in this case, and I can just search for it. And I don't have internet connection actually, so I will just show a different one first, which is something that we built ourselves. So I'm not sure whether anyone's aware of the crafting interpreters book. Yeah, okay, that's good. I hope so. Anyway, the crafting interpreters book works with this language called logs. And you're building a parser and an interpreter for that language and so on. And what we did was we built an example for Langdev for logs. And so to show like the feature set of Langdev and what you can do with that, you can essentially create a fully featured programming language and so on. And what we did eventually was we just noticed, well, we can write an easy interpreter for that language. And so what we did was we created a notebook kernel for that language as well. So we have some small code snippet that prints out some averages between a few numbers and so on. So we can quickly run that actually. It takes half a second to calculate 3 numbers, which is fairly slow, and that's because the interpreter is written in JavaScript. But it works, and so we can basically create, like I mentioned, any kind of kernel for any kind of language, for any kind of notebook that we like. And now for one last thing, I believe I now have internet. Yeah, I do. I can now fetch actually the open repository, the open issues from the Langdev repository. Yes, exactly. And now I can take a look at them, and now you will see some a great problem of those of the implementation. So usually when you open those, when you click on the link in VS Code, it will open the link in the browser. What it will do in Theia is just attempt to open it in the web view, which doesn't work right now. Okay, perfect. Anyway, so that's the basic gist of notebooks in Theia. We spent a great deal of work implementing those, and I think we've come along quite far actually. And so that's kind of it. So I'm actually at the end right now. So thanks for listening. Are there any questions?
So, you have any questions? Hi. Hi. I don't know if I missed something, but my question was regarding this interpreter that you show within at the end.
Yeah.
I didn't. The interpreter you say that you built it using JavaScript.
Yeah.
But you handcrafted it.
Yes.
Okay.
So the language itself is written using Langium and just like a bunch of small modifications to get everything working. And then the interpreter itself is just some JavaScript code that it's essentially just a tree walking interpreter. So it just walks through the AST nodes and just execute them as it encounters them. Pretty simple and fairly slow.
So it's okay.
It's just like 200 lines of code. It's nothing almost.
I have one question. I'm interested. In some notebooks, it's very useful to do things step by step. And then you need to keep track of the state, right? Of the side effects.
Yeah.
For example, loading and LLM or something like that.
Exactly.
You keep that. How do you deal with, if you have implemented or not, and how do you deal with the sessions that the interactive user is using to create the stuff, and sooner or later you have to destroy?
So in the Python, so it's a good question by the way. In the Python notebook, essentially there's just the IPython kernel, which is just taking care of all of that for you. I think you can also just, you can actually click on restart and you can restart the kernel and then it will just flush all the variables and so on. In the logs kernel, we actually forgot to implement that. If you create a cell, create a variable, and try to use it in the next cell, it will crash. Yeah, so that it's completely possible because in the VS Code extension, it's actually fairly simple to just like keep a context or a state and just pass that to the interpreter. But we kind of didn't do that. But it shouldn't be too difficult actually implementing that. And that's like the cool thing about the VS Code extension API. I've mentioned that writing a Jupyter Python kernel manually is fairly complicated. Writing a kernel for a VS Code extension is fairly simple because the API they've been working on it quite a lot, and it's now in a state where it's really, really good actually.
So I have a question related to this. I mean, which are the requirements for a language for one to be able to create a kernel for a language, a given language? Because I can imagine that it is more easily in I don't know, I can imagine trying to write a kernel for C++, very difficult, but what's are the...
I mean, it's usually way easier if your language is in somewhere interpreted, as in, be it something like Python, which is completely interpreted, or something like Java, which is first compiled to something, but then still interpreted.
You somehow keep the session of the interpreter open, and you keep sending messages to the interpreter or something.
Yeah, something like that. Essentially, it of course it depends on your interpreter. I mean, there's no interpreter for C++. I mean, not a real one at least, and so that becomes quickly very difficult. But yeah, I mean, of course the interpreter, or the standard interpreter for the language needs kind of some support for that at least. I know that by now, I believe the .NET stuff, for example, has support for that because Microsoft actually built an extension for building notebooks for like .NET, like F#, C#, and Visual Basic as well, in order to just have the benefits of notebook, which are generally just sharing knowledge, right? So that's fairly useful. But in general, yeah, you need to have a compatible interpreter. Without it, it won't work. Without it, you need to compile everything and then have it run as a standalone program, essentially.
Thank you. One more question we would manage. I assume that you can do this for textual DSLs?
Yes. Yeah.
Would it also work for projectional?
In theory, yes. So that's a good question. Well, we have a customer right now, which we're working with, that is working on modifying the UI of the notebook, which is just text and documentation right now. So it's right now, at least, well, the default is essentially just text and documentation. But they're working on something similar, which isn't exactly graphical cells, but it's modifying adding a kind of a different cell type, which could be, for example, graphical. So the API of Theia itself is extensible enough to actually add a new kind of cell and then eventually have it run in the kernel as well. So in theory, that's possible in Theia, yeah. But it's not out of the box because it's fairly complicated.
Thank you
All right.
much, Mark.
Thank you, everyone.